So I am going to check it with my condition if it is going to be in the flange, or the neutral axis is going to be in the flange, or it is going to be in the whip. So in order to calculate that, I need to calculate the MU limit value. So MU limit, you know that since it is M20 and Fe415, you know the formula 0.138 FCK BD square. So if I am going to substitute this value in this formula, 0.138 into FCK is 20 and B is 300 and D square is 310 square. So the value which I am getting is, the value which we are getting is 79.51 kilonewton meter. But if you see here, it is 130 and here it is 79. So MU is less than MU limit. So in order to overcome this, we can increase the depth. Since this condition, that is increasing the depth, we need to apply only in L beam. So I am going to assume D equal to, that is overall depth equal to 425 mm and effective depth will be 450 mm. Sir, you can ask, sir, if you are changing the value, it won't affect the value of this load calculation. Yeah, it will change, but we need to redo it. But in exam point of view, if we redo that, then the time will be not enough. So we are just assuming and we are using here. So after the changing this value to 445, we need to calculate again the MU limit. So the value is MU limit equal to, it is 149.6 kilonewton meter. So MU limit is greater than MU, therefore it is under reinforced. Therefore it is under reinforced. And since the twisting is there, we need to design for the torsion also. So next step what we are going to is, we are going to design for the torsion. So in order to calculate the torsion, first we need to calculate the equivalent moment as given in our code book, page number 75. So first equivalent moment is ME equal to MU plus MT. MU is which we have given from the got from the load, and MT is we need to use this formula and calculate the value. So next step is, we are going to calculate torsional moment, that is equivalent moment. So ME equal to MU plus MT. So we know that MU is, from this condition we know that the MU value is 130.37. So MU is 130.37 kilonewton meter. Next I need to calculate my MT. So in order to calculate the MT, if you see here, we will have this in our code book, that is MT equal to TU, that is torsional moment, into 1 plus D by B by 1.7. So MU equal to, I am going to write this formula, TU, that is torsional moment, 1 plus D divided by B divided by 1.7. So by using this formula, I need to calculate my value. So equivalent moment is ME equal to MU plus MT. So if you see in this code book, we have the previous step, we have MU equal to 130.37. So I have written that 130.37, and in order to calculate the MT value, I need to use this formula which was given in our code book, page number 75. So if you see here in page number 75, they have given the code book MT equal to TU into 1 plus D by B divided by 1.7. So I have written that here. So next I need to calculate the value, that is, so if you see here, I have substituted the value. If you see this in this condition, we have calculated the torsional moment as 79.5, sorry, here torsional is not load, it's torsional moment. So torsional moment is 50.67. So I have taken that value 50.67, and we have taken the depth, the overall depth as 450 mm. So I have taken 450, and width of the web is 300. So I have substituted, and the answer which we are getting is, the value is 74.51 kilonewton meter. So the total equivalent moment ME equal to MU, that is 130.37 plus 74.51. So the value will be, so it is 204.88 kilonewton meter. Next I need to calculate the equivalent shear, because if you are having a torsion, then we need to calculate these values, equivalent moment and equivalent shear. So in order to calculate the equivalent shear, in code book if you see, we have the formula as VE equal to VU plus 1.6 TU by B. This was also given in page number 75 of IS 456. So VU plus 1.6 TU divided by B. So we know that the VU value which you have calculated here. So the VU value is 94.25. 94.25 kilonewton. So here the value is 94.5 plus 1.6. TU is 50.67 divided by B is 0.3. So the value which we are getting is 364.74 kilonewton. So this is the equivalent shear. So in order to design, we need to use this moment and we need to use this equivalent shear. Next step, we know that we need to calculate the reinforcement. Calculation of reinforcement. So since it is less than that, so we need to design it as a rectangular beam. So if you take page number 96 of IS 456, we will have this formula: mu equal to 0.87 Fy AST 1 into D 1 minus AST Fy divided by FCK BD. So based on this, we are going to calculate the value. So here if you see, I have feed the value. I have taken this ME value, that is 204.88 into 10 power 6 equal to, I have substituted a value as we are going to feed in our calculator. So if you solve this, we are getting AST as 4183.5 mm square. So since it is a beam, I am going to calculate the number of bars. So I am going to use 25 mm dia bar. 25 mm dia bar, and I need to calculate the number of bars. So in order to calculate the number of bars, we know the formula: total area divided by area of one bar. So the total area is 4183.5 and the area of one bar is pi into 25 square divided by 4. So the value which we are getting is, so the value which I am getting AST is 4183.5. Next I am going to use 25 mm dia bar and I need to calculate the number of bars. So the formula is total area divided by area of one bar. So here if you see, I have substituted the value. I am getting it as 8.5. So we know that we need to round it off to the next whole number. So I am taking it as 9. So provide 9 number of 25 mm dia bar as main reinforcement. So next step is, I am going to calculate the check for shear. So first step is, we need to calculate the nominal shear stress, that is shear stress induced due to load. So the formula is tau V equal to VU divided by BD. So here if you see that we have calculated the equivalent shear, that is VU equal to 364.74. So I have taken that value here, it divided by 300 into 425. So the here shear stress value is 2.86 kilonewton per mm square. So next I need to calculate the shear stress in concrete, or shear strength of concrete. So shear strength of concrete, that is the formula is tau C. So before calculating tau C, I need to calculate the percentage of reinforcement, PT. So that is percentage of reinforcement. PT equal to, we know the formula because it was given in page number 73 of IS 456. So AST divided by BD into 100. So here we have used 9 number of 25 mm bar. So 9 into pi into 25 square divided by 4 divided by B is 300 and D is 425 into 100. So the percentage of reinforcement which I am getting is, so I am getting it as 3.46%. So if you look at the page number 73 of IS 456, if the percentage of reinforcement is above 3, then the value for M20 grade of concrete, the shear strength is 0.82 Newton per mm square. So I am taking it as tau C equal to 0.82 Newton per mm square. So here tau C is less than tau V. Therefore, shear reinforcement is needed. Shear reinforcement is needed. So since we are using the torsion condition, so we need to provide shear reinforcement as per the torsion condition only. So for that, take page number 75 of IS 456. Then we will have this formula, that is transverse reinforcement based on torsion is equal to ASV equal to, we need to consider the torsional moment also, and also we need to consider the shear force also. So I am going to write this formula which was given in page number 75, that is ASV equal to TUSV divided by B1 D1 0.87 Fy plus VU SV divided by 2.5 D1 0.7 Fy. So what is the value of B1 and D1? We need to find that now. So they are asking about the bar, so we need to minus the cover. So here if you see, I am going to consider ASV, that is I am going to use two-legged 8 mm dia bar as stirrups. So we know that we have the ASV value, so we need to calculate SV. So in order to calculate SV, what I am going to do is I am going to bring all the values here. So if you bring it here, so both the terms we will have 0.87 Fy and we will have the common term as D1. So that is divided by remaining, if you see here we will have TU divided by B1 value and plus I am going to have VU divided by 2.5. So if I am going to substitute the value into ASV, here we need to multiply it with ASV. So if you are going to substitute this value, so 0.87 Fy is 415 and D is minus cover, that is 425 mm, and ASV is two numbers, that is two-legged pi into 8 square divided by 4 divided by TU value. So TU value which we have calculated is 50.67 divided by B1, that is 300, and cover 25 means 250 mm, plus VU is which we have calculated, the value is, in previously we have calculated the VU value as 94.25, so I am taking that value. So 94.25 divided by 2.5. So the answer which we are getting is, so here if you see, it is in terms of Newton per mm square, this is in kilonewton meter. So into 10 to the power 6, here into 10 to the power 3. So if you substitute this, then we are getting the value as 64.2 mm. So I need to provide two-legged 8 mm dia stirrups at 60 mm center to center spacing. So with this we complete the design of L-beam. So as a homework, you need to complete the reinforcement detailing for this beam. So if you have any doubt, feel free to contact me. Thank you.